Hello, everybody. Welcome back to the Casual AI Talk series. After a long break from this, we're back and hopefully, we're going to be going steady again with these videos. I posted one of these polls on LinkedIn asking you what topics you would want me to get started with right off the bat, and you asked for AI coding agents. So, we're going to have a 7-part series about AI coding agents. So we're gonna start from defining what an AI agent is, and then going along the path of seeing, okay, how do we evaluate them? How do they come into play, into research, into actual development life? And along the way, of course, I'll be introducing a bunch of these what's it called, resources and papers and videos that you can watch to um, learn more about them. And yeah, as I said, today we're talking about AI agents. Nowadays, AI agents are apparently like the buzzword of the day. You throw an agent or the term agent around, and you have millions of dollars of VC money coming your way. But I feel like this term agent is being used quite loosely, so it makes sense to actually define what we mean by a AI agent. But just before we get into this, um, why has this become so important? I'm gonna give you a software engineering perspective on it. It's purely automation, because we as researchers and as industry have always been seeking to automate our processes further, to reduce the amount of bugs that we can have, ship faster or whatever. And here, these AI agents have been helping us um, get closer and closer to that goal of automation in terms of coding. But what does what is the distinguishing factor between a AI coding agent and a normal coding assistant? The way I look at it is that for the past few years, developers have gotten quite acquainted with these different AI functionalities inside the IDE. So we have autocomplete or chat. And nowadays, these auto completion features and such have become rather commonplace in terms of IDE features. You start to write code. The model predicts the next line or the next block, and you either decide to accept it or reject it. Chat is also pretty common nowadays. You ask it, okay, can you explain this chunk of code to me? What is this error? How would you refactor this class? And it gives you an answer. Both are useful in their own right, but the something's still missing from this workflow, right? You specifically have to decide in most cases, okay, which files you want to ask a question about. You need to decide what the changes are that you want to make, and ask how you make that refactoring, right? You decide when to run the tests. You decide when to copy a specific part of code and try to integrate it into your code base, and when you commit your code, right? Coding agents redefine this whole paradigm. Instead of fixing fixing with a bit of help of AI, you're essentially orchestrating a fixer to do your job. You task the agent with fixing the bug, adding this feature, updating the test, migrating your APIs to make use of this new shiny API that your library provides. And what the agent does, it inspects the repository, understands the tasks, and identifies relevant files which need changing in your code base, and proceeds with all the aspects that are related to that. So like running the tests, seeing whether you've introduced any bugs through a specific refactoring or a patch or whatever, and get things done like any normal programmer would. Uh, there's there's a simple distinction between AI agents and other AI assistants. A coding assistant helps you with what you're doing. A coding agent tries to do part of that task for you. I like to distinguish between AI coding assistants and AI agents in that specific manner. I know it can sometimes sound rather small, this difference that I'm mentioning, but it changes the research problem that you're dealing with, especially when you're in this academic or research setting. If so, because if your model is only completing a line, then we pretty much only care about the syntactic validity and local validity. But when your model is acting on this larger scale, such as an agent, we care about many more things. So, can the agent localize properly? So, can it find the actual file that it has to modify? Can it understand the project structure and all the complexities that are inherent to our code bases? Does it run the right tests? Does it run all the tests that it needs to run? Can it recover when it has an error? So we as programmers are quite familiar with how to take a step back, look at the errors that we get, and reiterate from that. Can a coding agent do that? And so on and so forth. So this changes the way we need to define the word autonomy, right? Like autonomy agent, right? So that's where it's coming from. A coding agent does not need to be fully autonomous, and we'll get back to this in later videos when we're talking about guarantees for these agents, which is a favorite topic of mine. And actually, if we're thinking about it, most of the useful coding agents that we're currently using in our day-to-day lives, like the Claude codes, the codexes, um, they're not like the fully autonomous, as fully autonomous as you might think. They have pretty rigid structures to them. They operate inside constraints. They have allow lists for what they are capable of doing and what they're allowed to do. And when they're given a task, they're given a specific repository, and they can act inside the bounds of that repository. But other than that, they should not be able to access other files outside of it, right? So they're still confined to the let's say the square of the repository that we have. Yeah, of course, they might have access to the terminal. They can do a bunch of commands to jailbreak themselves out of that sandbox. But the intention is that they should be constrained and also supervised by a human reviewer. I'll give you a concrete example, actually. So I'll take the example of GitHub Copilot's Cloud Agent that's been around for a while now. It can do a bunch of stuff. It can research a repository. It can create implementation plans, and you can actually use it from GitHub's interface, which is pretty neat. But you can ask it to do a bunch of different stuff, and there are fixed workflows that it can do. And this has been around for a long time. I'll also give an example of JetBrains Junie is also an AI coding agent that you can access through the IDE. It can execute a bunch of commands, multi-step actions, and introduce new features or fix bugs inside a large-scale repository. And this is what we're moving towards, these agents carrying out a bunch of these tasks that traditionally humans would be carrying out. And I feel like this whole notion of agentic AI is also shifting the paradigms in which we operate. So it's also where AI for SE, so AI for software engineering, starts to distinguish itself from a traditional AI, because a lot of people, when you say, "Oh, I'm a software engineer," or "Yeah, I'm a front end developer or a back end developer," they think, okay, software, they just write code and then ship it. That's actually not what we do as software engineers. We understand the bugs, we debug, we refactor, we understand the requirements that are present in the system and try to adhere to those requirements by doing maintenance, by doing code reviews, by doing proper development and deployment practices. And coordination with other people is also a very big aspect here. And because of this, I think it's very important to have a follow-up series, which was also actually one of the options to think about how we as humans incorporate these AI agents into our workflows. All right. that's about that, and introducing what AI agents are and how they work into our day-to-day lives. I want to highlight a specific paper that I really like, which is called "Challenges and Paths Towards AI for Software Engineering." I This will be one of the papers I actually include today in the list, but this paper provides like a AI for SE roadmap, and this was actually not that this is not that recent. It's like from a year ago, but it provides a really good grasp of what was then, and the vision is nice. So code completion and code generation is only a part of software engineering. There are so many other tasks that need to be studied to create capable AI systems that can actually mimic what we do as software engineers. So when people say, let the AI write the code, I think it's a bit too shallow of a statement. Let's put it like that. The the main question is that we should be asking ourselves is, how can AI and AI agents participate in the existing software engineering workflows that we have in our companies or research practices. Let's make this a concrete, simple example. I think that would help us. So you imagine you have this bug report, and a specific feature in your program fails, and you need to fix it. You ask your chatbot to explain plausible causes of this failure of the component, and yeah, it gives you a couple of options for how it could be that this component is failing, and then you start coding, right? You check out, you create a new branch for the hot fix. You use your normal IDE with code completion, but you're still doing the coding yourself, right? But then instead of this, what you could do is you could have a automated process which looks at your failure reports, for example, if you're collecting those as a large scale company, and tries to cluster those. And if the amount of a specific bug increases in terms of reports, it triggers a cloud-based agent that does localization, then actually fixes the bug, tests the code, and then immediately pushes and then asks for a human reviewer. And that also closes the loop a bit more and quicker, right? So because the action is quicker, the execution is there, but the control is still in the hands of the humans. And this is just a narrow example that I'm giving, right? You can take this example and broaden it to the entire software engineering life cycles at different parts, both in terms of development and maintenance, but also in terms of deployment and, yeah, after deployment maintenance, essentially. And I mentioned this part about the human reviewer because I'm a big advocate of putting them, because at the end of the day, somebody has to be held responsible when these AI agents do eventually make mistakes. So I think the human aspect of it is very important. And I think the community is converging on this, because we as humans can have a pretty good grasp of what is probably good for a project and what is probably not good for a project, and we should be able to make those decisions and be held accountable for those decisions that we make, like it has been the case. So throughout this series, so this 7-part series, I don't want to be the person selling the idea that coding agents are already replacing developers, because I do not think that is the case. That is, I don't think, an effective or useful framing at all. The useful framing, I think, for us to investigate at this point of time, at least, is what units of work are effective if they are replaced by AI agents, and what parts of the code of this workflow should still remain in the hands of developers. So let's recap. So we had in the beginning, I started talking about tokens. So this is the first video of the series, and you can go back to to these videos in the playlist. But we started with a token, then we went to line level completion, function level completion with a human level cell, prompts and tasks, and then we went to chat responses, and then now we have these coding engines that are kind of taking over. So with this shift from more autonomy towards more decisions towards the developer, going towards more autonomous decision making by the agents with oversight from the humans, I think there's been three consequences that have also been identified by the literature. There's also a really nice paper which is called the SWE bench. And this is also one of the papers that's in the resources. Three consequences have come about. So we identified that these models need tools. A coding agent needs a way to read files. So these models need ways to read these files, edit the files, search through the repository, run the tests, all that good stuff that we as developers do. And this motivates this episode that we're gonna have later down the line on agent computer interfaces. So how does a agent communicate with a computer effectively to get the information that it wants and to perform the action that it wants to do and is allowed to do? That's a very important constraint. So second is model context. So with this increasing autonomy, more context is needed to be able to actually execute those tasks. So real software projects are not isolated programs or tasks. They have specific conventions that you should adhere to. They have a specific style guide for how you implement stuff in terms of architecture, how you test stuff, and how you maintain that kind of legacy that they have in terms of their code. This is why we'll have a episode about repository level context, and I'm really excited about that episode that's coming up. And then finally, we need to be able to properly evaluate these models, because I've posted before about this. Evaluation is key. If we do not evaluate what we're claiming to do, then we're kind of inflating the numbers for no specific reason. If an agent claims to be able to fix a bug, we really need to double check whether it can do that. We have these benchmarks like SWE bench, which were created with this in mind intentionally, to solve with like code generation benchmarks. So essentially writing a feature or fixing a bug or whatever. SWE bench creates these like real world examples from GitHub through pull requests, and asks the model to create edits to resolve those issues. And I really like SWE bench, but of course it has its own limitations, and we'll address what these are. All right, I've been talking for quite a bit now. I just wanted to give you an overview of what we'll be talking about, and what the main concerns are in this 7-part series. So high level takeaways from today: AI agents are not just better autocomplete, as some people like to call it. They're systems that combine language models with a bunch of cool things like tools, contexts, actions, feedback, and some level of delegated autonomy and responsibility. So I'm super excited to be essentially unwrapping this whole topic with you. In the next episode, we'll go one level deeper and look at the core of these AI models, which is the agent loop. So how these systems reason, act, observe, and repair their own thought processes and work. So with that, I leave you with a question. I really want to start doing this from now on, to leave you with a question to just for you to reflect. So the question for today is, when you hear the word AI coding agent, what do you imagine? Do you imagine a better autocomplete, like a lot of people actually do? A junior developer, which is a common term that's being used nowadays? a pair programmer, or something entirely else? I would be more than happy to respond to you in the comments. I would be actually really happy if you send something in the comments. As always, thank you for your interest in this, and yeah, cheers. Until the next one.